Welcome, Algebra 2 class. We're going to learn about solving right triangles today. Chapter 10.2 in your books. If you don't mind, let's have a little discussion. You know, see, if I wanted to talk about sine, we know that that's like SOHCAHTOA. There's like a spider web on me. A SOHCAHTOA. Sine is opposite over hypotenuse, right? So if we're talking about sine of x, if I said I have a 60-degree angle here and I want to do this sine, that'd be the opposite side over my hypotenuse. That would be the square root of 3 over 2. So if I said, what's the sine of 60? You'd say it's the opposite over the hypotenuse. It's the square root of 3 over 2, which you could put as a decimal as 0.866. So that would be my answer. But what if I wanted to go backwards? What if I told you that the sine was 0.866? What if I said that's the answer? Could you go back and tell me the angle that got me that answer? Could you go back and find that 60-degree angle? So what you would do is you're going to learn about the inverse sine of x, right? So these are opposites. This is the sine. This is like the anti or the arc sine, the inverse sine, the opposite of it. It's what undoes the sine. So what I do is I say, what angle gives you the sine value that gives you the square root of 3 over 2? How did I get that square root of 3 over 2? Well, if I have this, what's the inverse? What's the backwards? Go backwards and map it. Go backwards from the square root of 3 over 2. If you do inverse sine on your calculator, inverse sine of the square root of 3 over 2, you're going to get inverse sine like that, right? It's that second, it's like that blue button, second sine, right? You do that, second sine of the 0.866, and you're going to get your 60 degrees. Make sure that your calculator's in degrees class, otherwise it won't work, because we have what's called radians later on, and the mode might be messed up. Next, we're going to go ahead and deal with our first example here, example number 1 on page 438, but let me take you on a little tour of the Landon farm. We're going to go see my lazy river and my pond. Okay, so right over here we have my lazy river. This is just the NID canal. The water comes down and fills my pond, and in a couple weeks we'll get my pond all filled up. But this little creek here is just a wonderful creek, and the water comes down. It's beautiful for summer days. Come on over here. So let's start here in example number 1. Example number 1 on page 438 says find the acute, that means the small one, less than 90 angle, whose sine is 3/10. So remember, we're going backwards. We're saying if I know the relation, if I know the fraction, the opposite over hypotenuse, could I go back and find the angle? So I drew a little triangle. That's called alpha. It just means like theta or x, like I don't know what it is. It's the angle, I don't know what it is, but I know that the sine of that angle is 3/10, opposite over hypotenuse. So if that's the case, then if I were to inverse sine both sides, right, if I were to anti-sine it, undo the sine, those would cancel out. I'd find out my theta, or my alpha, is just the sine inverse of whatever 3/10 is, right? So 3/10 is just 0.3, right? 3/10 is just 0.3. So if I take the inverse, that's the second sine of 0.3, you're going to get 17.45 as your angle. That's the degrees of your angle. So how would you know if you did it right? Well, then plug it in. If I put 17.45 right there, and I took the sine of it, right, check it. The sine of 17.5 will get 0.3. That'll be the relationship. It'll be 3/10. Well, come with me. I'll come show you some more stuff from the Landon farm. Can you see this? Okay. So when you're solving a right triangle, what exactly does that mean? Solving means you're finding all 3 sides and all 3 angles. So right here it says solve a right triangle, find all 3 sides and all 3 angles here. So if I have a triangle here, you notice I have the number 4 here. They gave that to me. That's an answer. 7's an answer, but they didn't give me side C. And they didn't give me that angle or that angle. And I know that's 90 degrees. So to solve a triangle, you got to find all 3 sides. You got to find all 3 angles. Let's go find some. Come with me into my orchard. This is my blessed persimmon tree. It's a sweet little God's natural tree. It's beautiful. And over here we have a persimmon. This is not a persimmon. This is a pomegranate tree or bush, right? But there was bees on it, so I have to be very careful. I'll just do some math for you right now instead of dealing with that. So if we took that same exact triangle that they gave me the 4 and they gave me the 7, I have to find the 2 missing angles. That's alpha and that's beta. And then I have to find the missing side, my letter C. So what I'm going to do is, let's just deal with my alpha. Let's just deal with the missing angle right there, alpha. If you notice, I have the opposite side 4, and I have the adjacent side 7. That's tangent, opposite over adjacent. So if I have alpha here, I go opposite, adjacent is 4/7. The tangent of this angle is 4/7. I wrote that here. The tangent of alpha is opposite over adjacent, that's 4/7. Okay? So if I know the tangent of alpha is 4/7, how do I undo that? How do I go backwards to find the angle? Is you anti-tangent it, you second tangent it, you untangent it, you inverse tangent it. So what you do is you tangent inverse that second tangent of that side and second tangent that side. When you do that, you get tangent inverse of whatever 4/7 is. That's just 0.571 in a calculator. And when you inverse tangent that, you get 29.7. So what that means is that this angle right here, this alpha, that's 29.7 degrees. And if you know that angle, then you could figure out that one really easy, because triangles have 180 degrees in the whole entire triangle. So if that's 90, because it's a 90-degree angle, and that's 29.7, you could subtract those from 180 to find out what beta is. So it says here, if a triangle has 180 degrees, and we know that angle C is 90, then alpha plus beta has to equal 90 also. So beta is 60.3 degrees. So what we found here is we found that one, that degrees, and that degrees. We have all 3 of the angles. Now we just have to find the third side. So to find the missing side, if I have two sides, I can use the Pythagorean theorem, right? A squared plus B squared equals C squared. Altitude, that's my height, that's the 4. B for base, that's the base, 7. So plug the 4 and the 7 in, that's 16 and 49, and that's going to equal my C squared when I add them up. So that's going to be 65. When you take the square root of that, you're going to get the square root of 65. That means that the C value is the square root of 65, and I found all 3 sides and all 3 angles. I have solved this triangle. And what I say is, we should probably go do another one, but I got to go out and show you my sheep. Before I show you my sheep, I'm going to do example number 3 on page 440, sitting on my nice Cub Cadet tractor here that my kids use to mow our lawn. So what we're going to do here is, there's these things called special triangles. There's 2 types of main special triangles. There's the 45-45-90 triangle and the 30-60-90 triangle. We're going to look at the 45-45-90. Now, if that's 45 and that's 90, we know those. This has to be 45 in order for it to add up to 180. That's why it's called 45-45-90, is that you automatically know the other one's 45. Okay? And so what we're going to do here is, if I've got, that means I have all 3 angles. I just have to find my 2 sides. Well, right here, I start solving it. In order to add them up to the 180, I find out my angle A has to be 45, like we talked about. And in a 45-45-90 triangle, the hypotenuse is the square root of 2 times either leg. This has to be memorized. I don't know what else to tell you. This has to be memorized. I want to say it one more time because it's really important. In a 45-45-90 triangle, the hypotenuse is the square root of 2 times either leg. So this value is the square root of 2 more than that leg or that leg, because the legs are the same. If they have the same angles here, then if you go across from the angle, that means the sides have to be the same also. A and B are the same in a 45-45 triangle. I just have to find out if this is the square root of 2 more, I go backwards. If it was the square root of 2 times it to get this way, I could divide by the square root of 2 and go back to the leg. So if I took my A value and multiplied it by the square root of 2, I'd get 5. So A times the square root of 2 gets me 5. My leg times the square root of 2 is 5. That's what this says. So in order to solve for A, I would just divide by the square root of 2, but you're not allowed to have square roots on the denominator. You got to rationalize that denominator. So when you multiply by the square root of 2 over the square root of 2, you get 5 root 2 over 2. That's your A value. And if that side is 5 root 2 over 2, then that side has to be 5 root 2 over 2, because those are the same in a 45-45-90 triangle, so we know our B value also. That means I know A and B, and I also know my angles. I've solved the triangle. I got A, B, and all my sides and my angles. All right, let's go see some sheep. Well, first I gotta show you my llama. That's my llama, Tina. She's named Tina after Napoleon Dynamite. But she's really skittish, so if I walk over, she'll get up. Watch, I'll walk over, she'll get up. Up there, you see? I just knew it. All right, let's go find my other sheep called Spot. Where's Spot? Spot's the only really nice one. She says hi to me all the time. Oh, she's right over there. All right, but let's do some math first. So, is this good lighting here? In a 30-60-90 triangle, this is the other type of special triangle. 30-60-90 triangle, it's important, it's a special triangle. It looks like this. See, I got a 30 degrees, I got a 90 degrees, which makes that 60. It has to add up to 180, remember. And so if I got all my angles, I just have to find my sides. Well, the relationship here, in order to add up to 180, my E value has to be 60, all right? And in a 30-60-90 triangle, here's what you have to memorize. The hypotenuse is twice the size of the short leg. See, the short leg right here is 8. This one's actually really easy. If this is 8, then the hypotenuse has to be 16, right? So look at this. So G has to be just 2 times my short leg. 2 times 8 is 16. That tells me my G value has to be 16. So the long leg has to be this one here, the E value, has to be the square root of 3 times the short leg. So if I take my value 8 and I multiply it by the square root of 3, I get this. So 8 times the square root of 3 is E. That's what I got here. 8 times the square root of 3 is E. And 8 doubled is my G. So just take your short leg, multiply by square root of 3 to get this. Take your short leg, double it to get that. Okay? Now let's go ahead and go find Spot. Where did Spot? Oh, there's Spot over there. She is rubbing her butt on the tree. Well, look at that. Would you look at that? Spot, what are you doing? Well, I was gonna go pet Spot, but I think I'm just gonna stand right here. Last problem we're gonna do, let's look over here. I got example number 5, and this is a roof. This is a house, but I was too lazy to draw the house, so I just drew the roof. This is R for roof, this is R for roof, and they give us this is 37.3 degrees. We know that's 12 feet, so here's the key to the problem. If that's 12 feet, then that has to be 6. We'll come back to that in a second. So it says, what is the length of the side of the roof, R? I'm trying to find R. If we know that that's R, this is 6, and then that's the 37.3. Well, notice, if we're at 37.3, we have an adjacent side and we have a hypotenuse side. Adjacent over hypotenuse, that's cosine. So it's a little hint. Hint is cosine's adjacent over hypotenuse. That's the data they gave us, so we're using cosine. The cosine of 37.3 is 6 over R. It's the adjacent over the hypotenuse, 6 over R. It's the 6 over the R. And so if I want to solve this one, I want to get R by itself. So I cross-multiplied. R times cosine of 37.3 is 6 times 1, so I get this. And then when I divide by 37.3, I'm going to get this right here. 6 divided by 37.3 is the cosine of that, and I end up with 7.54 feet is my R. That is my roof distance there and there, because it's the same. And with that, land it out.